Good morning. Last class we did how to create a text file, then we did get and put pointers, then get and put functions, and then how to take in from the keyboard, write it to a file, and how to read from a file and write it to the monitor. We also did the get line function wherein you can read the entire line. We did opening a text file and reading line by line instead of character by character, and we did what are binary files, how to create or write to a binary file, and how to read from it. So we did a program on that. Today's class, anyway, we have used EOF in all of those. We'll do EOF, that is detecting the end of file, because you need to stop somewhere. So if you are reading file, you need to stop at the end of file, right? So what is EOF? EOF is a special function provided by C++ which will give you a true value only when the end of file is encountered. So when it comes to the end of file, it gives you a true non-zero value, wherein if the end of file is not encountered, that is if still some data is left to read, then it will give you a false value. If we go through this, see, you have that if this is true, that is this is executed, these statements are executed on reaching the end of file, right? If it is equal to end of file, so you will get your true value. True is nothing but a non-zero value. Zero means false, right? So here only when this is true, that is when it reaches the end of file, then a set of statements you can write which you need to execute. So this one would return you a non-zero true value, whereas this is to execute a set of statements, that is not end of file. Means I am saying until the end of file is not reached, you will do this. Like this set of statements are executed as long as the end of file is reached. So here I am writing what happens when end of file is reached, and here I am writing what I should do when till the end of file is reached. That is, I have not reached the end of file. Please have a look and go through this. The next important topic and the last topic of this chapter is file pointers. So what are file pointers? File pointers are something which points to a position in a file which is determined by the offset, that is number of bytes from the beginning. Like where are you? Either what are the operations you can do on your file, the reading and the writing. So this pointer tells you where exactly the write pointer is and the read pointer is. For that reason, I would be using file pointers. See, normally when a program opens a file, to read or to write, it is sequential in order, right? But sometimes we may need to access the file in a random fashion. That is, I may not want to read the file from the beginning. I want to read it somewhere in between, or from the backwards, like end to the backwards I want to read. Like I don't want to read it from the beginning. So if you want to have the different locations in a file for reading or writing data, then every open file has two internal pointers called input pointer or get pointer and output pointer or put pointer. That is, if I want to access a file in a random fashion, not in a sequential fashion, I will have two file pointers, that is input pointer or get pointer and output pointer or the put pointer. These pointers, that is the get and the put pointers, get is for reading, put is for writing, because input is nothing but read and put is nothing but write. Okay, so I can read it in a random fashion, I can write it also in a random fashion. These pointers, what does it do? It facilitates the movement across the files while reading or writing. The input pointer, which is also known as the get pointer, points to the element to read. Okay, in the next input. Reading is nothing but an input operation, right? You are reading to the program, and writing out of the program is the output operation. So get is nothing but the input operation wherein it reads to the program, and then the output pointer is also known as the put pointer, that points to the location where the next element has to be written. That is output, where you need to write the next element in the output. You need to write, that is pointed by the put pointer. So when you open a file in a read mode, so when you say a read mode, what will be the mode here? iOS, scope resolution operator, in, right? When you open a file in this, the get pointer is positioned at the beginning of the file. By default, yes, it is positioned at the beginning of the file. Similarly, the way if you open the put pointer, that is iOS out mode, if it is iOS out mode, the file pointer is positioned at the beginning of the file. Sorry, the put pointer, the file pointer, put pointer is positioned at the beginning of the file. So only thing is, if you don't want to rewrite on already existing one, so what happens is you need to open it in the append mode. iOS app. Append mode means it will go to the end of file and point the put pointer wherein you can start writing, so that the contents in the file remain intact. That is, if you want to maintain the contents in the file, you don't want to rewrite on it, what you can do is, for writing you can use it in the append mode, so that it will go to the end of file and start writing from, because already present data is there, you don't want to erase it. Otherwise, if you don't specify anything, the get and the put pointers would be from the beginning of the file. And one more thing is, the file pointer is not an address. Whenever I say pointer, it's an address, right? So the file pointer is not the address, it is simply the offset or the number of bytes from the beginning or the end of the file or the current position. Like if I say I want to move 10 bytes from the beginning, then I need to start reading. So I can literally say 10. So when I say 10 bytes would be, in a text file each character is 1 byte, right? So 10 characters it will shift and then it will place the pointer there. Please have a look. The next is file pointer member functions. C, G. G is get, P is put. Tell G get and put. So this and this is used for reading. This and this belongs to the writing part. C, G. Move the get pointer to a specified location from the beginning of the file. So if I say around 20 something, if I pass as an argument, it will say it will move 20 bytes, that is 20 characters, because each byte is 1 character is 1 byte. So it will move 20 characters and put the get pointer there for reading, because I am using CG here. So get is associated with reading, correct? And put is associated with writing. So move the get pointer to a specified location from where? From the beginning. You can move from the beginning, from the current position and from the end. So when you are moving to end, from the end it will move backwards. Otherwise, in both the cases, like beginning, I need to move forwards. Seek P. Move the put pointer. Put is for writing, to a specified location from the beginning of the file, which is used for writing. This is used for reading, that is used for writing. Tell G. Tell will return you the current location. It will not move it or anywhere. Like you want to know what is the current read location and write location, pointer location of a in a file. So tell G will give you the function will return you the current position of the get pointer. Like get G is get. So wherever reading, when you are reading something, where is the pointer? The current location of that is got by tell G, and the same way tell P will return you the current position of the put pointer. Please have a look. So the next is file pointers seek G. So seek G, what is it used for? It is used for reading, correct? Move the get pointer to a specified location. So if I want to move the get pointer, get is used for reading. For a specified location, you have two syntaxes. One is two types. One is seek G long. It's an integer. Like I will give one integer, that many bytes it will move from the location. The other one is offset and seek dir. So if I say 20 from iOS current. So what it will say? From the current location, move forward 20 bytes, and then you start reading. So this is, I can also say the position, whether it's from the beginning. If I say only this, it will only be from the beginning. But if I don't want to always read from the beginning, wherever is the current position, from that if I want to move, then I can give that here. It will be from the current location, it will move to that particular, that many bytes it will move. So you just have a look. This we will do in detail again. See, the seek G long is an integer, moves the current pointer to a current get pointer, that is for reading, to a specified location from the beginning of the file. That is what I said. Like you cannot specify that from the current location or from the end or from the beginning. So if I just give this, it will move 20 bytes from the beginning of the file, and it will place the get pointer there for reading. That is, it will get pointer would point to the 20th byte in the file from the 0th byte, because 0th byte means from the beginning of the file to the 20th byte, and one character is 1 byte. The next is file pointers seek G. Have a look. So file pointers seek G. It has two arguments. The second one, see, if I say only one number, if I specify, it will be always from the beginning. But then I may not want to do always from the beginning. So it has two arguments, that is the offset and the seek dir. Offset indicates the number of bytes, like how many bytes I need to move. That is indicated by the offset. And what is the direction? So I can move backwards also. Like if I give a negative number in the location as end, then it will move backwards that many bytes. So the three things, directions, like the seek dir can take three arguments. One is IOSBG, that is offset specified from the beginning of the file. If I say 40 IOSBG, from the beginning or the 0th byte, 40 bytes would be moved forward. Or if I don't specify anything also, it would be taken as beginning. But from the current, I would have read the file halfway through, I would have read, and I want to skip some data in between. So I don't want to move it from the beginning. I can say from the current location, wherever is the get pointer, from that location move the pointer specified number of bytes. Then when you reach the end, if you want to move backwards, then if I say 6, it will like -6 iOS end, it will move 6 bytes backwards. Minus because I am moving it backwards, not the forwards. Please have a look here. See, these are the functions, options I can have. Just now what we discussed, I had put it in a table. This is the file object dot seek g are 0 iOS beginning. Get pointer to the beginning of the file, because 0 is the beginning of the file, right? And then 0 iOS end, go to the end of file just directly, because I am not specifying 0 by itself, it will go to the end of file. Then 0 current, stay at the current location, don't move. Wherever is the get pointer, it would be placed there only. Now if I say m, so m is a number, right? M would be an integer, that is the offset. Move get pointer m plus 1 byte in the file. So iOS beginning means from the beginning of the file. If I say 20 here, move the get pointer to the 21th byte from the beginning. So if I say m current, move m bytes from the current position, like wherever, suppose if you are in 50th byte position, if I say 20 bytes, it will go to 70th byte. So that many bytes it will skip. So from the current location, here I am giving minus because I would be moving backwards from the end of the file. Please have a look. Now we'll start with seek p. So p is for put pointer, that means it's for writing. Okay, move the put pointer to a specified location from the beginning of the file. Again, similar to the seek g, you have two types, that is seek p long, wherein you will get one given number here. From the beginning it will move that many bytes, or you can set the direction like seek dir is from the beginning, end, or the current, from the current location, and offset is the number, like if I say 10 bytes, 20 bytes, whatever, I can give that as the offset input. Please have a look. So this seek p, the other one, offset and dir, it has two arguments. Offset indicates the number of bytes the put pointer is to be moved from this direction. So this can have these three arguments. It can be beginning, current location, and end. It can be from the beginning, from the current location, or from the end. Offset and seek dir. The offset indicates the number of bytes you are going to, it's a number, how many bytes, like in a text file each character is like 1 byte, right? The offset indicates the number of bytes that the put pointer is used to move from seek direction, like whatever is the 3, whether it's from the beginning, the current location, or the end. But then if you are moving from the end backwards, it will be a minus, negative number, because you are moving backwards. Otherwise a positive number is moving forward. So file pointer cp, this is the object t file dot cp 0 iOS beginning. From the beginning you are going to write, and this one directly go to the end of file, then you will continue writing further, or you can open in the append mode also. And this one is stay at the current position for writing, then go forward m bytes from the beginning of the file. So this one, if you give 0, it will be in the beginning. If I say 10 bytes, so it will skip 10 bytes from the beginning, and from the 11th it will start writing. Then minus, because it is backwards. To go backwards m bytes from the end of file, you need to give minus. So next you want to know the position. Where is it? We did seek G and seek P to move the file pointers, that is the get and the put pointers. But to know the current location of the get or the put pointer, you can use tell G and tell P. These are the functions which will give you an integer value, wherein which place it is. So it will give you the location which is an integer. Where is it? Suppose if it is in the 10th byte, then it will give you 10. So the purpose of the function is to return the current position of the get pointer is tell G. So then you can decide you want to move further, backward, or you want to stay in the current location. So if stream class provides a member function tell G. The purpose of this function is to return the current position of the get pointer, which will be an integer. That is why I am having an integer variable here which will hold the return value. The same way I have tell P which will return me the current position of the put pointer. So position of put pointer. Fine, the get and the put pointers. So we have come to an end of the files chapter. We completed C++ with this, which is a 39 mark weightage chapters in the final exam. Along with that, like we started from the 5th to the 12th chapter, that is 5th to 12th chapter is C++, which is review of C++, and then we did classes and objects, function overloading, constructors and destructors, inheritance, pointers and data file handling. We also did practical programs. Apart from other programs, we also did practical programs associated with it. So hope you have understood this. And next we'll be starting with data structures. So please have a look of this. Then we'll start with the objectives of data structures. What are data structures and what are we going to study about it? Now we'll start with data structures, which is lecture 4, which is a very important topic, and the weightage of this chapter is 14 marks of theory and 15 marks practical. Okay, so part A is nothing but C++ and data structures using C++. So theory is for 14 marks and practical is for 15 marks. And in theory you will get one 1 mark question, one 3 mark question, and 2 5 mark questions. So you will get 2 5 mark questions, 1 3 mark, and 1 1 mark question from data structures. If you are aiming for 100, then you have to be thorough with this, and still it has 2 5 markers. So do pay attention to this chapter. So let us start with the objectives. So what are we going to study in this chapter? So we'll be starting with data structures. Like, what is data structure? See, data structures are basically the algorithms, like how do you store there, like how to store data and how to retrieve, and what is the relationship between the elements which is stored. So you can implement it using any programming language. Whatever may be the language, the data structure doesn't change. That is, the array is an array in C++, C or Java. You don't change the structure of the array or the relation, the logical relation between, or the relation between the elements and the operations performed on it, the way it is stored. Like it's a homogeneous set of elements, yet it has to be homogeneous set of elements only. Like you don't find arrays with heterogeneous elements in any other programming language. So data structures are concepts which can be implemented using any programming language which is used for storing and retrieving data. Data structures and how are they classified? We'll be doing data structures using C++. And then operations on, like classification would be primitive and non-primitive data structures. Again, in non-primitive also you have linear and non-linear data structures. So what are primitive data structures and what are the operations, what you can do with that? Like you can create, you can destroy or delete, you can update, you can assign a value. So all these things are some of the operations performed on primitive data structures. So what are primitive and non-primitive data structures? Again, in non-primitive we'll study about linear and non-linear. How are they different and what are the operations performed on them? Again, we'll be starting with one-dimensional array. We'll study one-dimensional array here. Array would be a data structure. So in that, how can I insert an element into an array? And it can be in the beginning, end, or at a given location. And then how do I delete an element from an array? Again, it can be from the beginning of the array, end of the array, or at a given location. Main as at a given location, beginning and end you can do it. And then searching techniques we will be doing. What do you mean by searching? Searching is nothing but finding the element in a list of elements, whether that element is there or not, and you have different techniques to do that. End result would be same. Like if you are searching for an element, either the element would be there, it will not be there. If it is there, then you will find the location of the first occurrence of the element, because you are not checking how many times the element is there, but you are checking for the occurrence of that first occurrence. So searching technique result would be same, but the technique performed will be different. So you will be studying linear search and binary search, the difference between the two. And data structures will be writing algorithms as well as programs for each. Algorithms are 90% times asked in your theory exams, whereas in practical the programs would be asked. Then we have sorting. So what do you mean by sorting? Sorting is nothing but arranging the elements in a list in an order, either in ascending or a descending order. So sorting technique will be doing insertion sort this time. Last time we did bubble sort. Last year we did bubble sort in your 11th. So this year we'll be doing the insertion sort. Again, the end result, like if you're sorting an array in ascending order, then the result would be same, but the technique would be different. Then stacks again is a linear data structure. The operations are push and pop, that is inserting an element into a stack, and pop is nothing but deleting an element. And we'll be studying about the array based representation of stacks and queues. You can also have pointer based, but for your syllabus we'll be doing array based representation of stacks and queues. So push, pop operations, and what are the other different applications, or what are the applications of stacks, and we'll also be doing polish notations here, the different kinds of expressions like infix, postfix, and like how to convert an infix expression to a postfix, and from postfix to infix. Then you will also do prefix, like you will do different kinds of expressions. How do they get evaluated in stack? Like actually when you perform, how does it like gets pushed and popped, and how actually the operators work on operand, and how is the intermediate result stored? All that we will be doing in stacks. Next is queue. So we'll be doing queue insertion, queue deletion, and what are the applications of queues, and the different types or variations of queues we'll be doing. We'll also be doing the difference between the stacks and queues. All this like array, stack, queues, linked lists are linear data structures. So linked list, what is a linked list, how to create, and how is it different from arrays, and how to add a node, delete a node, insertion of a node, deletion of a node, and the beginning, end, or at a given location. How do we store data? How do we logically, how the node is pointing to one another? How is it linked? All that we'll be doing in linked lists. Then we will do the introduction, like we don't have programming here, but then trees is very important for 1 and 3 markers. The definitions like the depth, all that they will ask you, the degree of a tree, the depth of it, all that will be either a 1 marker, or if multiple of that is asked, then it will be a 3 marker question. So what is a tree, and how is it different? Like what is the difference between a linear and a non-linear data structure? Like the difference, major difference would be the relation, how the relation between the elements are placed. Like relation between the elements in non-linear, the relation is hierarchical, whereas in linear it's a linear relation. Okay, and then we'll just have an introduction about graphs. Graphs will just what is edges and all that we will study, but then there are only definitions, but we will be doing in depth, like what is an array. We'll be doing a linear search, binary search. In this they will ask you either the algorithm, the program, or the trace. It will be a 5 marker. The trace can be given wherein you need to trace the algorithm and arrive at a result. And even for insertion sort also, then insertion of an element, deletion of an element, or frequency of an element, all these are your practical questions which will also be useful for you in your theory. So if you know the algorithm, you can easily convert it into your program, or vice versa. Then stacks and queues are definitely important for 5 markers, and linked list is a 3 marker question. Trees, normally it's a 1 marker, or sometimes it comes for 3 marks wherein they give you multiple definitions. So we'll do all this. We'll also be covering the practical part along with the theory part. So if you have a system, you can execute it and see. Please go through the objectives. Next, let's start with basic definitions. So what is data? Collection of raw facts. Like it is just facts. It may not be meaningful. It's a collection of raw facts. Information is something, data in a meaningful form. So data is just collection of raw facts. For example, student marks. Each student mark is a data, wherein the information would be whether the student passed, failed, if he has passed, what grade he is placed in, what is the maximum marks he got, minimum he got, and overall in the class where does he stand? Does he qualify for further studies or not? All these things would be information. Just the marks of the student would be a data. It's just a collection of raw facts. Getting it? Then data structure is a representation of the logical relationship existing between the individual elements of the data. Like, for example, you take an array because you're familiar with an array. So what is an array? It's a homogeneous set of elements stored physically next to one another. So what is the relation? It's linear and it is next to one another. If I traverse in this direction, I will go on getting the next element in this direction also. Or I can directly randomly I can access the element using the subscript, right? So an array, that is the relationship between the elements. For example, if it is a tree, it will be in branching like this. It will have a hierarchical relationship to retrieve. It will not be one next, it will have a hierarchical relationship, whereas an array would be linear. So data structure, representation, logical relationship. And if it's a linked list, you will have a pointer which would point to the link, or a pointer which points to the next node. So what is the relationship between the elements, like individual elements? Because when you have to retrieve, when you have to traverse, when you have to insert, or when you have to delete, performing all this, or sorting, searching, you should know how they are related so that you can traverse in a proper way. So data structure is a representation of logical relationship existing between individual elements of data. Or you can also say it's a specialized format for organizing and storing data in memory that considers not only the elements stored but their relationship to each other. So please go through the definitions. Then, why do I need it? Because utilization of space by data in memory and optimization of time taken for processing. Yes, it's an advantage of data structure. It provides a means to manage large amount of data efficiently. Yes, if it is have a proper structure, then any operations performed on that would be easier, right? Data structure, that is why, provides a means to manage large amount of data efficiently. Like you can sort, search, actually store, retrieve. If it is organized or structured, like properly stored, then you can efficiently manage it. Data structure means organization or structuring a collection of data items in appropriate form so as to improve the efficiency of storage and processing. Storage and processing. Yes, you need to store it and then you need to process it. Again, you store the processed data. So that is a cycle, right? So if you have an organized structure and then you have proper algorithms to access it or retrieve whatever the operations you are going to do on that, then you can write code using any programming language to do that. So these are again about data structures. Please have a look. Now we'll go through the classification of data structures, which can be a 3-marker. If you can write this, you will get full marks. So many times the representation, pictorial representation, would fetch you better marks rather than writing it one below the other. So when they ask you classification, definitely you can write this kind. Data structures are classified into primitive and non-primitive data structures. So primitive, you have int, char, float, pointer, long, double. All this comes under primitive data structures, which can be directly operated by the at the machine level. Like, I don't need a structure. Int x, it can be directly processed. You don't need a structure to insert, retrieve and all. I just create it, store it, I can edit it, and if it's a pointer, I can even destroy it, like release back the memory. So in all this comes under primitive data structures. Then you have non-primitive data structures. In non-primitive, you have arrays and lists, or I can say again linear and non-linear, because in some textbooks they have given linear, non-linear. In linear only arrays, stacks, queues and linked list are put. You can write it that way also, doesn't matter. So arrays, you have one-dimensional array, two-dimensional and multi-dimensional. You have done arrays chapter in your 11th grade, right? And you had one-dimensional, two-dimensional and multi-dimensional arrays. In one-dimensional array, you did what? Fibonacci series and all that you did, I think. In one dimension, searching an element or frequency of an element in one-dimensional array. In two-dimensional array, that is matrix, you did the addition of two matrices, multiplication, transpose, then scalar matrix or not, all that you already did, which was a only dedicated chapter to arrays. And what are multidimensional? More than two dimension is multidimensional arrays. Here we'll be mainly dealing with single dimensional array. One dimensional array, all the programs like searching, sorting, insertion, deletion, checking of the frequency of an element, everything using 1D array. Then again in list you have linear and non-linear, like the relationship between the elements, linear relationship. These elements will have, this elements will have a hierarchical relationship among them. So linear, in that we'll be doing stacks. In stack, what will we do? In stacks we will be doing push, pop as well as polish notations. And then in queue we will do DQ, that is deletion, DQ, NQ, insertion, deletion, and we'll also do different variations like priority queues, double-ended queue and singly queue, all that we will do. Then you have linked list. Linked list also we will be doing node creations and how the nodes are created, how are they linked to one another, and what are the different variations of a linked list also will be done. And in non-linear we will do trees, but we will not be doing any programs on that, and graphs, just an introduction. Have a look. So now we'll start with primitive data structures. So what are primitive data structures? Data structures, those which are directly operated upon by machine level instructions. So which can be directly operated upon machine level instructions. You don't need any algorithms to follow, right? You can directly, if I say int x, then it directly gets operated. That is depending on integer means 2 bytes of memory would be allocated. So data structures that are directly operated upon the machine level instructions are known as primitive data structures. And these are the basic data structures that can be directly operated upon by machine instructions. Example, int, char, float, string, pointers fall into this category. Please have a look. The primitive data structures, what are the operations performed? So I can create, yes, select, that also I can do. What do you mean by select? If something is true, print this. Like if I say, if I have to compare two numbers and print the larger of the two. So selection is based on the condition. If x greater than y, if it is true, print x, otherwise y. So create, select, update. Update means like I can give an initial value and I can go on increasing it, decreasing it, or I can assign a variable x is equal to y also I can do, where y has some value. So the value of y gets substituted into x. So it gets updated, and I can delete it also, like provided it's a pointer. I can delete or release the memory used. So that is create, select, update and delete. These are the most commonly used operations on data, primitive data structures. Next, non-primitive data structures. So these are more sophisticated data structures. You need to follow the steps or the rules to insert, delete, traverse. This even for storing, retrieving. There are more sophisticated that are derived from primitive data structures, like data structures that are derived from primitive data structures. For example, an array. So array is a homogeneous set of elements. If I say integer array, again integer is a primitive data structure. A collection of integers becomes an array. Or I can have a float array. I can have a string is nothing but a character array. Data structures that are derived from primitive data structures are called non-primitive data structures. And non-primitive data structures are group of homogeneous, that is the same data type, or heterogeneous data items. When I say heterogeneous, you can think of structures and unions wherein you can store heterogeneous set of data in them, whereas homogeneous is even a class can have different kinds of data in that, whereas homogeneous, definitely yes, a queue, a stack. Actually stack, yeah, it is a homogeneous set. You will have an integer stack or a character stack, and then you can have an array. Yes, array is again a homogeneous set of elements. So everything belongs to a non-primitive data structure, which is a collection or which are derived from primitive data structures. Primitive data structures are data structures which can be directly operated by machine level instructions. Please have a look. Next is linear data structures. Linear data structures are kind of data structures that has homogeneous element. And one more important thing in linear data structure is a linear data structure exhibits an important property called as adjacency. ADJACENCY, between the elements, whereas non-linear, it's hierarchical. Okay. Are very easy to implement since the memory is organized in a linear fashion. So some commonly used linear data structures are stacks, queues and linked list, and we'll be doing all the three, and one of them is array also. So arrays, tags, queues, linked lists will be doing. Please have a look. That is, the elements are in a sequence and form a linear series, and which exhibits the property of adjacency between the elements. Next is nonlinear data structures. A nonlinear data structure is a structure wherein data item is connected to several other data items. So, which has a hierarchical relationship. That is, it will have a hierarchical relationship between the elements. May exhibit hierarchical relationship or a parent-child relationship. In a tree, you will have a parent node and a child node. So when you study trees, you will have that parent node and a child node, wherein data is stored right subtree, left subtree, and again it would be stored like this, the root node, and then you go on storing. That's not in a linear fashion. So it will have a parent-child relationship or a hierarchical relationship, are not arranged in a sequential order. And the different non-linear data structures are trees and graphs. Please have a look. Next, the operations which can be performed on data structures. This is a commonly asked 3-mark question, a very repeated question which is very easy. Traversal, what do you mean by that? Visiting each element once is a traversal. Like example for that, you can just check, compare or search. Traversing is nothing but visiting each element at least once. Insertion, inserting an element. Selection, selecting an element based on a condition. You can select or just you can pick an element from a list. Searching, sorting, merging. Merging means I have two arrays, I can merge those two together. Destroy or delete. I can also free the, actually when I do linked list, I'll create a node, and when I delete a node, I free that memory to heap so that it can be reused. So all these are different operations performed on data, non-primitive data structures. So difference, please go through this. The next class will be starting with, we'll continue with this and we'll start with arrays. Please note down the homework questions for today. First one, what are data structures? Second question, what are primitive data structures? Third question, give any two examples for what are non-primitive data structures? and give 2 examples. Fourth question. What are the different operations performed on primitive data structures? Or I can say non-primitive. Let it be non-primitive. List the operations non-primitive Please make a note of this. Hopefully you have understood. Take care. Stay safe. Bye-bye.